Hello everyone. Hello everyone. Today you will see that we have taken three classes 1, 2, 3. In all the three classes we have taken water. This is water. This is water and this is also water. And we have taken three lemons 1, 2 and 3. Today we will experiment with these lemons whether it is floating or it is going downwards. Let's see. If we put this one in this glass, let's see what happens to it. See, it's good, goes down and goes down bottom of the glass. Let's see what happens in this case. If we take this and put it in this water, let's see what happens. You see, it also goes down. And if we take this one and put this in this glass of water, we'll see what happens. In all the cases you see, they are in the bottom 1, 2, 3. Now we'll discuss about the laws of flotation. Why it is downing, why it is downing, what is downing, whether it can be floated or not. Let's see what happens to it. First one, you take out this one, take out this lemon and we are putting salt in water to increase the density of this water. If we put salt here, let's see what happens to this. We are taking salt. Here you see, we are taking salt 1 and 2 and mix salt with this water to increase the density of the liquid. Here increases the density of this water. Right? Now, if you put this one, let's see what happens. Yes, it is floating. Right? Here you see, the lemon is floating now. Right? This lemon goes down, but this lemon goes up or it is floating. The question is why it is floating and why it is going down. And what is the case in this glass of water? Let us see once again. If we take out this lemon, we take out this lemon and put salt in this water again. And mix salt with this water. And let's see what happens. Now if we put this lemon, what happens? We see. Here you see, it is also floating. Now if you add some water to this, let's see what happens to this one. Now if we add salt to it, some more salt, and mix with this salt with this water, let's see what happens. Now see, all the three cases are different from one another. It is flowing, this lemon is floating on the surface of water. This is in the middle and this is lemon goes down. Why this happens? The reason for this is can be explained with the help of Archimedes Principle. What is the Archimedes Principle? That if we drop an object, suppose this one, see this one, this lemon is drowning or it goes down. Why it is the case? And it is in the middle of water, but it is in the top of water. What is the reason for that? It can be explained with the help of Archimedes Principle. Archimedes says that if an object is immersed in a fluid or let it be liquid, the liquid it displaces by this object, and the weight of the object says whether it will be goes down, it will be in the middle, or it will be in the surface of water. Let us take the first case. In this case, what happens? This is water, this is lemon, right? When we drop this lemon, it displaces the water as its volume. And if we measure the weight of the liquid displaced by this lemon and weight of the lemon in air, we will find that the displaced water is heavier than this lemon. That the displaced water is lighter than this lemon. Now, the displaced water shows the force of buoyancy. The force of buoyancy acts upwards, but weight of the object goes downward. Now you see here we can say, since the density of this lemon is greater than the density of water, that's why the lemon goes down. Because weight of the lemon in air is greater than the weight of the displaced water by this lemon. That's why it goes down. Because the water displaced by this lemon is the upward buoyant force. Since the weight of the object is greater than the buoyant force, it goes down. Right? Now you see in this case, or in this case, case number 2. In this case, what happens? You see, the lemon is in the middle of water, neither upward, neither downward. Why is this case? The case is that when we put this lemon in water, but we have put some salt in water to increase the density of water. Right? That means when we weigh this lemon in air and the water or the salty water displaced by this lemon will be equal. That means the salty water displaced by this lemon and the weight of the lemon is equal. Or you can say that the water displaced by this lemon, the salty water displaced by this lemon, weight of the salty water displaced by this lemon is equal to the weight of the lemon in air. That means you can say that here in this case is W1 is equal to W2. In this case, W1 is greater than W2, but in this case, W1 is equal to W2. W1 is the weight of the object in air, and W2 is the weight of the liquid displaced by that object. In the third case, you see here, this is the third case. Here you see here, the lemon is on the surface of water. What is the reason behind this? It can be also explained by Archimedes Principle. Here you see, when we put salt in this water, right? To increase the density of this water. We increase the density of this water, right? We increases the density of this water. And when we put this lemon, it displaces some water. And if we measure the displaced liquid or displaced salty water and weight of the displaced salty water and weight of this lemon, we'll see that the weight of the displaced salty water is greater than the weight of this lemon in air. That means the buoyant force is greater than the weight of the object. That's why it goes up, because the buoyant force is greater. Right? Or we can say that W1 is less than W2. W1 is the weight of the lemon and W2 is the weight of the liquid displaced by that lemon. But here you see, we've increased the density of water. Now we can come to the conclusion that if the density of the object is greater than the density of the liquid, it goes down. If the density of the object and the density of the liquid is same, it will float in equilibrium. That is, it goes neither upward, neither downwards. In the third case, since the density of the liquid is greater than the density of this lemon, that's why it goes up. Because here in this case, the buoyant force is greater than the weight of the object. In this case, the buoyant force and the weight of this object is same. That's why it is floating in equilibrium. But in this case, you see the lemon is in bottom. That means the weight of the lemon is greater than the weight of the liquid displaced by this lemon. Right? Equal volume of displaced liquid by this lemon. That's why it goes down. Here, in this case, the weight of the object is greater than the buoyant force. Here in this case, the weight of the object is equal to the buoyant force. That's why it is in the middle of the glass. But in this case, you see here the buoyant force is greater than the lemon. That's why it goes up. Or in a nutshell, you can say that if the density of this object is greater than the density of the liquid, it will goes down. If the density of the object and the density of the liquid is same, that it will float in equilibrium, that it goes neither upward, neither downward. And in the third case, this is the third case. In the third case, if the density of the liquid is greater than the density of this object, then the object will float. This is what Archimedes says. According to flotation, laws of flotation, that's why it is going downward. It is in the middle of the surface of water and it is on the surface of water. Or in a nutshell, you can say if the density of the object is greater than the density of the liquid, it will immerse or it will goes downwards. If the density of the liquid and density of the object is same, it will float in equilibrium. That means it will goes neither upward, neither downwards. And in this case, if the density of the liquid is greater than the density of the object, then it will float according to Archimedes principle. Right? Now, we can explain what is Archimedes principle. Archimedes principle states that a body immersed in a fluid experiences an upward upthrust equal to the weight of the fluid displaced, and this is fundamental to the equilibrium of the body floating in still water. A body floating freely in still water experiences a downward force acting on it due to gravity, and this is what we say it as Archimedes principle. That means Archimedes principle states that a body immersed in a fluid experiences an upthrust equal to the weight of the fluid displaced, and this is fundamental to the equilibrium of a body floating in still water. Right? Now, we have explained the three cases in these cases. If we take case number 1, first of all, weight this object in air, and if we weigh the liquid displaced by this object, we will find that the weight of this object is greater than the weight of the liquid displaced by this object. That's why it sinks or it goes downward. In this case, if we weigh this object in air and if we weigh the liquid displaced by this object, you will find that the weight of the object and of the weight of the liquid displaced is same. That's why it is floating in equilibrium. That means it goes neither upward, neither downward, and in all the cases it follows the Archimedes principle. In the third case, you see the weight of this object in air is less than the weight of the liquid displaced by this object. Right? That's why the upthrust or the buoyant force is greater than the weight of this object. That's why it goes up. In this case, the buoyant force and the weight of the object is same. That's why it is floating in equilibrium position. It goes neither upward, neither downwards. But in this case, we see that the weight of the object is greater than the weight of the liquid displaced by this object. And if we have changed the density in these both the cases, here the density of water is more than the density of this object, and here the density of water is same as that of this object, and here the density of water is less than this object. In this way we can define Archimedes principle or laws of flotation. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.